Welcome to Physics Prep. This is a question from TATA-GS 2019 and it asks us to find the kinetic energy of electrons so as to see diffraction effects. The thing about diffraction effects is that to see diffraction effects, the scale of the metal lattice, which is basically the spacing of the metal lattice, must be somewhat similar to the wavelength lambda of the electrons. And if we are talking about particles and then we are talking about wavelength, then of course the de Broglie wavelength shows up, which is lambda equals to h by mv. However, we need this in terms of the kinetic energy, and we know that the kinetic energy, let's call it K, is half of mv squared. Putting this equation into an easier form to translate, we have Km equals half m squared v squared, or root of twice Km equals mv. Now this we can put direct here to get lambda equals h by root of twice Km, so that we have the kinetic energy that we need is equals to 1 divided by 2m h squared by lambda squared. So this is the relation that we will be using to get our answer. All that remains to do is find the value of the kinetic energy by plugging in the values of h squared, which is 6.6 times 10 to the power minus 34, and this is squared, divided by 2 times mass of the neutron, that is to the power minus 27, times 4 into 10 to the power minus 8 whole squared. From this we get an answer of 8.056 times 10 to the power minus 22 joules, and we have to convert it into electron volts by dividing it. So kinetic energy in electron volts is this, divided by 1.6 times 10 to the power minus 19, which then gives us 5.11 times 10 to the power minus 3 electron volts, which means B is our answer.